Hello, and welcome back to Teacher Gimbal channel. I know I've been gone for a while, but if you're a returning user, thanks for coming back. And if you're a new user, make sure to like or subscribe. It's a button that's down in this corner or maybe the corner over there. Now, I've been gone for a few months because I've been working on a different project. We just created a website called rateyourprincipals.org. If you're a teacher, head on over to it and you can rate your principal for school year 23-24. Now, let's get started on today's lesson. Today we're going to be going over Illustrative Mathematics, Geometry, Unit 2, Lesson 1. Let's go. Problem number 1. When rectangle ABCD is reflected across line EF, the image is DCBA. So I have ABCD. Let's make my pen small. I always like to trace my figure so I know which one I'm talking about. Is reflected across line EF. Now remember, when you're reflecting across a line, especially one that's in the middle of the figure, what's happening is this side is flipping onto that side, and that side is flipping onto that side. So it's kind of like you're folding the image in half. The image, when we reflect over EF, is DCBA. So the image is actually the same figure as we started with. How do you know that segment AB, so AB, put one line, is congruent, so the same shape, the same size, to segment DC? Well, intuition says if we flipped this side onto this side, or this side onto this side, AB lines up or corresponds with DC. So because AB corresponds with DC, we can conclude that they're congruent. But let's look at our answers. A rectangle has two pairs of parallel sides. This is a true fact, but it doesn't tell us that AB is congruent to segment DC. So I'm going to cross them out. Any two sides of a rectangle are congruent. That is true, but does that tell us or does that prove that the segment AB is congruent to DC? I feel like it should. So we're going to put a question mark on this one, but we'll come back to it. Congruent parts of congruent figures are corresponding. Congruent parts of congruent figures are corresponding? That's not true. If I have this figure here and this figure here, that isn't true. And we'll talk about that later. Post in the comments if you want me to explain that, but this actually doesn't make sense. The phrase here says corresponding parts of congruent figures are congruent. This side corresponds to this side, and therefore we know that the figures are congruent. I think B, any two sides of a rectangle are congruent. That doesn't necessarily mean AB and AD are congruent, or that says AB or AD. It's not any two sides. It's specifically the sides that are across from each other. How do we know they're across from each other? Actually, we know that by reflecting from here to here. So this two sides isn't specific enough because it could mean the short side and the long side. What we need to know is the two sides that correspond to each other, they're of that rectangle, correspond to each other, and therefore they are congruent. All right, so we're going to cross them out. Again, I move pretty quickly, so these videos aren't too long. If you have any questions, make sure to pause the video and go back over that section. Now we have question number 2. Triangle FGH is the image of isosceles triangle. Triangle FGH is the image of isosceles triangle. Okay. Sometimes I have to read something twice to make sure I understand it. I'm trying to get all the answers in the one screen. Nope, I don't think I can. So we have FGH, which is the image of isosceles triangle FEH. Oh, I think this isn't supposed to be here. After a reflection over line HF. So we have FEH right here. We got reflected across HF. This right here, although it seems kind of out of place, it says FE is congruent to EH. So we have FE is not working. And oh, there we go. FE is congruent to EF, HE. Any of your teachers know the struggle it is when your whiteboard marker or your chalk or your smartboard isn't working, so thank you for being patient. FE is congruent to HE, which makes this top triangle an isosceles triangle, and he was reflected over line HF. Select all the statements that are a result of the corresponding parts of congruent triangles being congruent. So EFGH is a rectangle. So EFGH. I don't know if he's a rectangle. He doesn't look like a rectangle, but that's not necessarily true based on the fact that corresponding parts of congruent triangles are congruent. FGH has 4 congruent sides. Well, if this guy corresponds to this guy, we know that they're congruent because corresponding parts of congruent triangles are congruent. And if this side is corresponding to this side, he's also congruent, which actually then tells us 1, 2, 3, 4 sides are congruent. So this guy is correct. Diagonal FH bisects EFG and EHG. So we have to remember the word bisects means it's split into 2. And if we split something into 2, that means both sides are going to be the same. So I have to look at what's being bisected. We have diagonal FH, which is right here, bisecting angle EFG. Well, if EFG is right here, this is going to be the same as this side because, again, it's a reflection and they're corresponding. And EHG, this side is going to be the same as this side because it's a reflecting. So yeah, it does bisect. Diagonal FH is perpendicular to side FE. FH is perpendicular to FE. No, that's not a given. And then we're going to move forward. So remember these answers as we look at our last one. Finally, we have angle FHE is congruent to angle FGH. So angle FEH, this one right here, is congruent to FGH. This side corresponds to that side, so this one is true. All right, we're done with this question. Pause this video if you need to look back, and I'm moving on to the next one. Reflect right triangle. Let's delete everything. Reflect right triangle ABC across a line BC. Classify triangle ACA prime according to its side lengths. Explain how you know. So, we're taking triangle ABC, which is to our right. Someday I'm going to get this tool correct. So ABC, and we're reflecting it across a line BC. So A is going to come, he's going to go right about there. I'm going to call him A prime. B is on the line, so he's going to stay there. B prime's right on top of him. And C is also on the line of reflection, so he's going to stay right there. And now I have this new triangle, which I'm going to outline in blue, and that's our triangle ACA prime. Well, I know because I just reflected it that this side has to be congruent to that side. And technically this side is congruent to this side. But this whole triangle, the only thing I know is that A prime C is congruent to AC. That tells me that this is an isosceles triangle because 2 sides are the same. We're done. Let's go on to the next one. Problem number 4. Triangles FAD and DCE are translations of triangle ABC. Let's see if I'm all on the same page. Okay, hopefully you can read this. Nope, it won't go any smaller. So we have select all the statements that must be true. So we have triangle FAD and DCE. DCE are translations of triangle ABC. Okay, so this guy right here, this guy, and this guy are the same triangles that have just been slid over. That's a translation. So I'm going to go ahead and do a little bit of drawing before I even go on to the questions. Triangle FA has to have the same size as this triangle right here, and the same side right there. The second side is going to be the same here and the same there. Because remember, we just slid that triangle there, and slid over here. And then this bottom side could be the same as this bottom side right here. Those marks are kind of confusing to me, so I'm going to go ahead and I'm going to put a different color for each side. The pink sides correspond and I'll grow it. Blue sides correspond and I'll grow it. And then we're going to have yellow sides correspond and I'll grow it. Now we need to select all statements that must be true. B, A, and F are collinear. Well, he slid down here as a translation, and it's lined up, so yes, they must be collinear. The measure of angle BCA is the same as the measure of angle CED. BCA, so the skinny guy, is he going to be the same as CED? Yeah, it's the same triangle slid over, so this is true. Line AD is parallel to line BC. AD, so this guy's, and BC. When you slide them down, so you slide that yellow line down, they end up parallel. So the translation just moves it down. It doesn't change the angle of any of the sides. So yes, this is also true. The measure of angle CED is the same as the measure of angle FAD. So we have CED. This guy here again, is it the same as FAD? Those guys do not correspond. Is not a correct answer. E says the measure of angle DAC, so DAC, this guy right here, make a big dot, is the same as the measure of angle BCA. BCA? That's not necessarily given. Actually, you know what I see? We said the yellow lines are parallel, and if you notice, that makes a transversal. These are actually alternate interior angles. But this one is also true. And then, let's go down to the last one. I'm going to delete these, so pause real quick if you need to go over it. Triangle ADC, so we have triangle ADC, is a reflection of triangle FAD. No, those lines don't correspond. We're not given that it was a reflection, so we're going to cross them out. That is wrong. All right, let's go on to the next one. Problem number 5. We only got 2 left. Okay, this one's going to involve a lot of explaining, so make sure to pause and get your pencils out if you're writing down this answer. Triangle ABC is congruent to triangle BAD and CEA. So ABC is the same triangle as BAD and CEA. So all these guys are the same triangle. Explains why DA and E are collinear. Explain why DE is parallel to line BC. So collinear means on the same line, which means DAE, this guy right here will have to be 180 degrees. And we're going to have to show that. The fancy word for geometry for showing is proving. So let's talk about this angle right here. We have this angle, ABC, and he's congruent to BAD. So this triangle is the same as that one. A would be the same angle with B. Does that make sense? Because this triangle is the same as that one, that A corresponds to B. And we're going to take this angle right here, and that's the C, which corresponds to B. It's the same as this angle right here, and also the same as this angle right here, right? Because the C corresponds to the A in the third triangle, which is this guy. Then we have this angle here, the B of this triangle, because that's ABC, is going to correspond to the A of my second triangle, so he's the same as this guy right here, and is going to correspond to the E of this triangle right here. Now, if you remember, triangles add up to 180 degrees. So if pink plus blue plus yellow equals 180, pink plus blue plus yellow equals 180, means he's aligned, which means all these guys collinear. Now, how do we know that DE is parallel to line BC, EE, and BC? Well, if we take this line right here, and be careful here, we see this guy and this guy are congruent, and they are alternate interior angles. And if our alternate interior angles are congruent, we can conclude these lines are parallel. And we're done. Make sure not to use this line because that angle and that angle aren't made by the parallel line, so that angle's not going to work. Which is why I chose this one, because it's the transversal and the parallel line, and transversal and parallel line. All right, we got one question left. Question number 6. Let me move this over. Identify a figure that is the result of a rigid transformation of quadrilateral ABCD. So we have quadrilateral ABCD. Now remember, rigid motion is a translation, a rotation, or a reflection. And we want to know when that's a result. Well, if I rotate him 180 degrees, I have the same shape right here. There we go. We rotated 180 degrees. That's a transformation. We're done. There's actually a bunch more you can find, but I'm going to let you go ahead and find those on your own. Describe a rigid transformation that would take ABCD to that figure. We did it. If I rotate this guy, AB goes on top of BF. This side's going to go here. That side's going to flip all the way around and go here. AC is going to go to HG. And then BC all the way to HB. Alright, if you have any questions, comments, or if I made a mistake and you found it, please put it in the comments below. As always, please like and subscribe by hitting the button that's somewhere over here. And remember that if you're a teacher, make sure to go ahead and check out writeyourprinciples.org. I'll see you in the next video.